All of JKEM's 200 series controllers come with USB communications, USB ports, and free KEM-Net software, and that's what I'm starting right now. When KEM-Net first starts up, it goes out and it searches the USB bus for any controllers that it can find. This can connect up to 6 different controllers, and those controllers, if they're multi-channel ones, for example, a quad, it could even connect 6 quads, which would be 24 meters on the screen, and it can plot and data log all of them. In this case, I only have the one controller that we've been running, our Model 210 timer. Remember that we asked it to heat to 80 degrees, and so the first thing the software does is it shows you a real-time display of the temperature controller. The second feature of the software is anytime I want to, I can start charting that controller, and the chart will be real-time. And then I can also data log my reactions. I can tell it to start logging, and I can, if I had multiple controllers, they would appear right here in a list. But I only have the one controller connected, and so I'm going to tell it I want to log the actual temperature of the solution. If I wanted to, I could tell it to also log the set point. And I'll come back to this feature. I can tell it to log power. It's simple. You can just simply enter how often you want it to take a point. But this smart logging, I don't know if you can see this on screen, but right here, smart logging is a great feature. Let's say you were going to log a reaction for 5 days. Well, you don't really want to take a data point every 5 seconds for 5 days. It'd be an enormous file, and it'd be a waste of disk space. So what smart logging does, it says that I want you to take a data point, for example, once a minute. But if something changes in my reaction, if there's either a deviation high or a deviation low, by the amount I tell you, and I would make it small, I'd make it 0.2 or 0.3 degrees. If there's a deviation, then I want you to start logging every 5 seconds. So what's good about that is you could data log a reaction that's going to be running for 5 days, but if there was an exotherm, immediately it goes from slow data logging to fast data logging so that you can exactly define the shape of that exotherm. Either way, I've asked it to just simply do simple logging right now, and it's going to ask me for a name of a file. I can give it any name I want to. And so once logging starts, you can see up here in the upper right-hand corner of the meter, an L will appear to indicate that it's data logging. Another feature of the KEM-Net software is creating ramp programs. So I'm going to create a ramp program. You do that in an Excel style table. You can have up to 32 ramp and hold steps. So for example, I can ask my reactions to start at 23 degrees. I want it to heat to 100 degrees, and I want it to heat to 100 degrees at a rate of 10 degrees an hour. Once it gets to 100 degrees, I want it to hold it there for 60 minutes. So that's my first ramp and hold step. Now my reaction is at 100 degrees. I can ask it to perform a second ramp step and go to 120. And maybe this time I want to get there more quickly, and so I'm going to say heat at 50 degrees an hour. And I want it to hold there again for an hour. Ramps can either be in a heating direction or in a cooling direction. So now my reaction's at 120, and I can ask it to cool to 50 degrees at 5 degrees an hour. I'm not going to enter any sort of a hold time. If you don't enter a hold time, and it's the last step of the program, then it just stays at the final temperature indefinitely. Now that I've created my ramp program, all I need to do is click the button, upload it to the meter, which I just did, start the program, and the meter displays R up here in the upper right hand corner to show you that it's ramping. And I don't know if you can see it on your video, but right here in this green text box, they're showing you the ramp step, the current set point, and there's a timer here at the lower portion showing you when that ramp will complete itself. For this whole run, we've been data logging, heating the reaction here, and you can see it on the screen. This would be very typical of the results you would get. So we started at room temperature. It's going to heat to the set point. I've asked for 80 degrees. It's also typical that you would have a slight overshoot. In this case, we overshot by about 1 degree. If you can see the peak of that, it's at 81 degrees. It'll overshoot to about 1 degree, then come down, and then it will be at 80 degrees plus or minus 0.1 degree indefinitely. The reason for the overshoot is we can get rid of that if you want to, but it's a compromise. If you want to get rid of the overshoot, then the initial heating, the slope of this curve is shorter and longer. And most chemists would prefer, when they enter a temperature, basically it's get my reaction up there, get it up there as fast as you can. And so it's a compromise. This heats quickly. You have about a 1 degree overshoot, and in any reaction that I know of, 1 degree is completely immaterial. But what we find the greatest safety feature of JKEM's controllers is I ask for 80 degrees and I have 80 degrees. We can come back in 3 days and that line will be flat and straight. I have 80 degrees. I can set the controller and walk away from it as soon as I do that. There's another feature of Chemnet that I would like to show you. It does require an upgrade to the software. Chemnet itself is free, but there is an $80 upgrade to Chemnet Pro. And what that is used for, there's two things. It's in logging. The normal Chemnet will data log to an Excel file, but the Chemnet Pro data logs with GMP compliant data. Additionally, the Chemnet Pro can log the power that's being delivered to the heater. And the important thing about being able to monitor the power being sent to the heater is you can imagine in this run right here, what if there was just a very mild exotherm? In most cases, you would completely miss it because the temperature controller would see that there is a small increase in temperature and it would do exactly what controllers are supposed to do. It would cut its power to that heater. It would turn off its power to that heater so that it doesn't overshoot the requested temperature, 80 degrees. But what that does is that masks the exotherm. But if you were able to plot the power going to that heater, what you would see, even if you had a flat line, is all of a sudden you would see that power was at a steady level and then it decreased and it came back up. And so by able to data log the power delivered to the computer, you can monitor for an endo or an exotherm in your reaction. And also, as I said, the Chemnet Pro allows all data to be logged in a GMP compliant format. There is one more very advanced feature with Chemnet, and I'm not going to go over it in this video, but you would be welcome to call us and we can review it with you. It's called KEM-IO. With the software, you can create conditional programs. So KEM-IO allows you just have to think of that as being able to turn on or off other pieces of equipment as a function of time or temperature. It also can be used for alarms. You can program special high and low temperature alarms, so a great safety feature.